Ellie, do you know Justin Norquist? I taught Justin Norquist, just in case. Okay. Uncle Justin, just in time flying. Take a look-see here, ladies and gentlemen. Are you ready? Take a deep breath, because your life is about forever to be rocked. Today we are looking at, this is called classifications of numbers. Oh, that doesn't seem to. What's up with that? Oh, why didn't you tell me?
I forgot.
Somebody tell me that don't know what's going on. My favorite, my absolute favorite application on computer is this little snippet thing. It is the best. Here we go. Ready? Yes. Thank you for that. Thank you very much. Okay. This is our classification of numbers. Classification. And this is a helpful little chart to help you kind of remember it. Alright? You will notice there is a very large box. You see the biggest box? Okay. Carlos, you with me? See that very large box? That very large box contains all of the real numbers. Okay, all of the real numbers. And ladies and gentlemen, for all intents and purposes, the only numbers you know are real numbers. Which should be nice, because if I asked you to give me a real number, Ephraim, you would say 8. 8's a real number, very good. Another real number?
77.
77, it'd be a little more creative. How about 7/8, or 5/16, or 3/10, or 0.07, all those are real numbers. Which would lead you to say, just as a sidelight, if there are real numbers, guess what? There are also, well, we don't call them fake, Donald Trump.
Unreal.
The ones out, yeah, well, that's close. The other ones here that you will never get to are called, and we'll talk about a little bit in 8th grade, they're called imaginary numbers. Imaginary. You don't know right now any imaginary numbers, and you don't need to, but I just thought I'd make you aware of them. Okay? Now, inside of all of the real numbers that you know, that's what these other little boxes. Everything we put in this thing is a real number because it is in the big real number box. Okay, but there are smaller boxes here, that are parts of those real numbers. And the first subheadings we have are what are called the rational numbers. And if that's this box on the right, it's the rational numbers. It would be all of these numbers here in this giant box right here. By the way, all rational numbers are real numbers. And if we have something called rational numbers, guess what? We have also something called irrational numbers. Very good. And that is this box right here. Irrational. Now, irrational numbers, if you think about what those words mean, irrational numbers don't make sense. They're irrational. Okay? And here's the nice thing about irrational numbers. For you, there are only 2 types of irrational numbers you just have to think about. Okay? There's only 2 things you have to think about. The first one is this little thing we call pi, which I don't have up this year. Okay? The reason why pi is an irrational number, does anybody know? Oh, we do know. Charlie? Yeah, it never ends. So you really can't use it for anything. I mean, you can because you're just going to get close enough, but people have done it out to hundreds and thousands, I think, of decimal places, and it doesn't work out. The other thing that's an irrational number are? Nobody? Square root things that don't work out. For example, the square root of 2, the square root of 3, the square root of 5. The square root of 4 is not in this category because there is a square root of 4, it is 2. But if you type these other square root things in there, in a calculator, you get the same thing that pi gives you. You get a decimal point that never ends. So they fall under the it doesn't make sense category because they're irrational because they don't work out nicely. Got that? So there's your only thing you have to remember with irrational numbers is that pi is an irrational number and any square root, the square root of 15, doesn't work out. So it's irrational. Square root of 25 does work out, so that's not irrational. But the square root of 26 would. Oh, got that? Good. Now, rational numbers then are all the other numbers that don't fit into this category. Rational numbers are anything that you could have a fraction. I suppose I should change that to red, shouldn't I? Just to make it consistent. Fractions are rational. Decimals are rational. Okay, any of those things are rational. But inside the rational box, we've got smaller boxes and smaller groups. And then the first one we're going to do, I believe, is the integers. My boxes are not very good. Now, please understand this. Because the integer box is in the rational box, every integer is going to be a rational number. But not every rational number, like these two, will be integers. Okay? Integers, does anybody know what integers are? Integers are simply positive and negative whole numbers. Positive and negative whole numbers. So examples of that would be 7, negative 8, negative 4, 0. Notice there are no fractions or decimals in the integer category. Fractions and decimals are just rational numbers. They're not integers. Now, somebody might try to trick you and put 16 over 2. 16 over 2 is an integer because when you simplify it, it's 8. And it's the same thing as 8. So it is an integer. Okay. Wow, we are doing so well here. And then under integers, we have what are called the whole numbers. Again, every whole number is an integer, and every whole number is a rational number, and every whole number is a real number because they fit in that box there. Whole numbers are simply the numbers that start at 0. They're all positive, and there are no fractions. It's simply 0, 1, 2, 3, 4, 5, and they go on forever to the right. You don't have negative numbers. It's really the same thing as integers without the negative numbers. Again, I didn't make this up. This is all math stuff that they taught, told me to teach you. So. And then the last box, what color shall we use? Yes, green, good call. What said that? The last box is the natural, or what is also called the counting numbers. And the natural counting numbers, natural counting numbers, natural numbers, counting numbers are the same thing as the whole numbers, except there is no 0. Identical to the whole number. So it starts at 1 and it goes forever to this way. And a good way to remember that is this. When your mother and your father taught you to count, when you were 1-year-old, 2-year-old, or whatever they did, okay, remember, maybe you don't remember, but they went 1, 2, 3, 4. Notice they did not start with 0. Do you know why they didn't start with 0? Because there's nothing there for you to tell the person to count. If you just said 0 to a little 2-year-old, they would have no idea what you're talking about because there's nothing there. You go, that's 0. There's nothing. But if you had 1 apple, you could say there's 1 apple, 2 apples, 3 apples. Once you get that, then you can go, now there's 0 apples because there's nothing there. But that comes a little bit later. Now, with that being said, ladies and gentlemen, the book might ask you to give, we call all of these things sets of numbers. This is the set of natural numbers, the set of whole numbers, the set of whatever. They might ask you, they'll give you like the number 7/8. And they'll ask you, 7/8 belongs to what set of numbers? And then you look at your handy-dandy little chart and you'll say, well, it's not a natural number because there's no fractions there, there's no fractions there, there's no fractions there. Fractions start right there. So 7/8 belongs to, well, and it belongs also, it belongs to the rational numbers and it belongs to the real numbers. All numbers that you know are going to belong to the real numbers. If they gave you -16, -16 belongs to what set of numbers? Well, there's no negatives here, there's no negatives there, negatives start there. -16 belongs to the integers, it belongs to the rationals, it belongs to the reals. It belongs in all those categories. Usually we go for the more specific one and you would say just integers, but that's neither here nor there. How about that for fun and excitement?
Yes.
Who feels that this has just been the best day ever? The other thing we need is you need a blank piece of paper because we just have to brush across this. Make sure you write this in appropriately enough. Blank piece of paper. We are going to talk about absolute value. Absolute value. And you may or may not like this. I don't quite matter too much to me. Hey,
On our homework, you want us to write real numbers too, or what it belongs to?
if it asks you to, it might ask you. The book might ask you the number 6 belongs to what subsets of the real numbers. Then you wouldn't have to say real numbers because it already told you it belongs to. But if it said what sets of numbers it belongs to, you could always throw it away. Absolute value, ladies and gentlemen, here is an example of something. If they ask you what absolute value is, they might give you this, -5, and then they put these little goalposts by it. This and this are the absolute value signs. That's the absolute value sign. Okay? And simply put, in layman's term, the absolute value, when you see that sign, it is just asking you how far is that hashtag from 0. Question mark. And I'm going to give you the mathematical thing before you figure out what the easy answer to this is. So if you had a number line, and here is 0, and you have -5, which is this. Uh-oh. Give myself a little room here. I have -5. What is the distance from this to this? How many units is that? From -5 to 0 is, do I have to count off for you? Can you just get the rib? What is it? 5. And that's what the answer, the absolute value of -5 is 5. Okay? What if I asked you for the absolute value of just a +5? Well, if you look at that same thing here, 1, 2, 3, 4, 5. How far is +5 from that 0? Tough one. Olivia? 5. Guess what? The answer to both the absolute value of a -5 and the absolute value of a +5 are both 5. So if you wanted the simple little directions that get you there every time, you can simply say this. Absolute value makes everything positive. And the reason for that is because distance can never be negative. You can never go -8 miles. You know, if I go from here to Yorkville, that's 4 miles. Even if I drive in reverse, I'm still going 4 miles. You can't go a negative distance. Okay? Your height can never be -5 feet tall. Okay? You just can't be. Okay? So where I see most people go wrong is they think absolute value changes things to their opposite. So I'll see them do this. You know, they'll say, oh yeah, -12 is 12. but they'll say the absolute value of 15 is negative 15 because they think it changes to its opposite. It does not. Absolute value of 15 is still a positive 15. It's how far it is from 0. Ladies and gentlemen, this ends your first day of the rest of your life. I don't know if there'll be anything else there that will give you trouble. Most of it's pretty simple. Open your books to set number 1, please.